Another very easy Leetcode hard problem. Hello everyone. Today we are solving Leetcode daily challenge max dot product of two subsequences. So in this problem we are given two arrays nums1 and nums2 and we to return the maximum dot product between non-empty subsequences of nums1 and nums2 with the same length. And as you know, subsequence of an array is a new array which is formed from the original array by deleting some can be none of the character without disturbing the relative positioning of the remaining characters. 235 is a subsequence of 1 2 3 4 5, while 153 is not because the order has been changed, right? So we are well aware of subsequences, but what is this dot product? So let's say I create the subsequences 2 and minus 2, and from nums1 and from nums2 I'm taking 3 and minus 6. So dot product is that for every corresponding indices. So let's say for 0 indices 2 into 3 plus for 1 indices minus 1 into minus 6. Let's say I had x over here and y over here. So all this value plus x into y, right? So it will be 18 plus x into y. So this is what we mean by dot product, and that is why it has said it has to be of same length, because if they are of different length we cannot compute this dot product, right? So what can we do? So if I see the constraint, I see over here it is 500, so I can easily have a 2D memo state, right, in order to store a state. That here the very first intuition was that I have to make choices, right? I have to create subsequences and I have to make choices. Now I'm left with, should I be considering this element for my subsequence or not? If yes, okay, then continue. But what if it is for I and j? So we have to take this both into consideration. That is why 2D I'm considering. Okay, now what? So one thing is that in order to have this dot product, I also needs to maintain the size of both the arrays to subsequences to be the same, right? So I have to take that thing into consideration. Another thing is that it has to be non-empty, right? So let's me give you a bit idea with the code that will help you more. So what I've done is I've created this for memory state. I've created this dp 3D array. So what it is doing for I and j, as I told you, I'm considering 501 for my I. This is for jth. Now why? What the hell is this do? So this I have maintained that as of now for I and j, whether are there any elements that I have taken into dot product or not. So what I, inside my max dot product function, what I'll do is I will first initialize dp with -1, right? Next I will pass this I value. So I value is starting from the last value of nums same sorry, nums1, and same with nums2, last value of nums2, and passing this as 0, right? As of now I don't have taken in any dot product into consideration. As of now it is empty, right? So here we are, this is my function ij nums1 nums2 and 0. Now let's define the base condition. So if my I goes less than 0 or j goes less than 0, that is the out of bound condition. In that case what we'll do is we'll see that if 0 is equals to 0, that is, have we taken any pair for my subsequences or it is still empty. So if 0 is equals to 0, that means no, we have taken anything, it's empty. So in that case what I'll do is I will return int min by 2. We are returning a very large value, sorry, very large negative value, because we have, in order eventually we have to maximize it. Here if you see we have to maximize it. So if we have not taken anything, return very less value so that it comparison becomes easy. Otherwise return 0. Okay, makes sense, makes sense. Base condition makes sense. Now as we have in memory state that dp of ij 0, that have we taken this state before or not? If we have calculated, why to do the rework, right? Just simply return that value. Now here comes the meat part of it. I've taken four variables over there: take I, take j, take both, take none. So don't get confused. Take I, take j is basically whether I'm moving I or not. I and j, we are going back. If you see, I've started from the very last index. So take I will mean that I will go by one index back. Take j will mean that I will go one index back, right? And take none is let's say, so take none is basically I'm going both the indices back, but my 0 will remain 0, that I haven't taken any dot product into consideration. So take none means that. Now if I will check if I is greater than 0 or not. If it is, then I'll do is take I. Take I means that I'm going back by one index, but j will remain the same. So uh, there might be possible that these are of different length, right? And the last element would not be matching with the last element. It might be with the second last element, third last element, or the very first element. So in that case, I have to be flexible enough that I can freely move both my indices uh, independent of each other. So that is why I check quickly that my I is greater than equal to 0. In that case, I you reduce my I by 1 and j remains the same. And I'll continue this recursive function. And I update the take none with the maximum, whatever value I'm getting from take none or take I. Update that in take none. Same I will do with take j. I'll check first that j should be greater than equal to 0. In this case, I will don't touch I, let I remain the same. I will move j by one position back. Similarly, I'll update take none with take j or take none, right? Considering it as a variable, that is up till now, we have gone up to 3 cases and take none is the maximum of all. Another very important case is when both my I and j are greater than 0. Now I'm taking both, right? I go one index back, I go by one index back, sorry, and here I update my 0 with 1. Why? Because if you see plus nums of I plus nums of j, so this is the pair that I have taken as a dot product part, right? So now take both means that I go back by for both and I update my 0 that I have found it one pair, and I will add it in my recursive call that nums of 1 of I into nums of 2 of j, right? And finally dp of I, j and 0 will be maximum of take both and take none, because take none was handling all the cases where we were not taking any pair into consideration, but we are moving ij freely or independent of each other. And take both is we have taken both indices, we have moved both indices, but we have also taken this into account and updated that I found at least one pair, I got it, so it won't be 0 at the last. So this case satisfies that it will be non-empty. For the subsequence part, we are handling all the 4 cases, how the movement would be, right? So yeah, this was for this question. If you have any query, please do let me know in the comment section. I will love to clear your doubts. If you like the video, please subscribe. It gives me motivation to keep creating such content. And if you like the video, do like it. So thank you.